Hello everyone. So today we are going to be talking about traversing a graph in Python. More specifically, something called depth first search. So basically visiting every node once and not revisiting any node. So first of all, let's draw a graph. So in case you don't know, a graph is just something that looks like this. So it has nodes that are labeled by any sort of value, I guess. You could use numbers or even strings or whatever. And there are edges that connect those nodes. So like this, hold on, let's just draw this out real quick. Okay, and then maybe another node here, 4, and then connect everything together. Right, here we are. So now that we have a graph, well, graphs can be used to represent a lot of different things. You could use graphs to represent a map, or maybe like you could use a graph to like sort of plan out a route you have to take to like visit every node once, or problems like that. So we're going to look at how to go through a graph, go through every node of the graph once without repeating any nodes, and we're going to implement this in Python. So like a path we could a traversing path we could use is we go from 0 to 3, and then 4, and then 1, and then it sort of stops here because we can't get to 2 because 0 and 3 have been both visited before. So yeah, another working path could be from 1 to 4, and then to 3, and then to 0, and then to 2. And then that traverses through the entire graph, and no, we do not revisit any nodes. So let's see how an implementation of this would work in Python. So let's do this. So this is called depth first search. So basically visiting every node once. Oh, I've already said that like 20 times. So anyways, we have this. So one way to represent a graph is through an adjacency list. So an adjacency list is basically a list of different numbers. Oops. Oh, so I lied. It's not an array of numbers. It's actually just a list of lists. So essentially, the element 0 of the list is going to represent node number 0. So the list in the list with index 0 is going to represent the node 0. So so we are going to write a list for every single node there is. So we can have, so this represents 0, and then let's add, and then this represents 1, this represents 2, this represents 3, and this represents 4. So yeah, these are all the this is like a template of an adjacency list for a graph with 5 nodes, and then we just write the ID or the number of every node that node 0 is connected to. So if we look at the graph again, we can see that node 0 is connected to node 1, node 3, and node 2. So let's write that down. Hold on. So this represents node 0. So we're going to put 1, 3, and 2 here. Or let's just put this in order. Yeah, that's good. And then for node 1 is connected to node 0, 3, and 4. Node 2 is connected to node 0 and 3. And node 3 is connected to nodes, oh god, that's a lot, 1, or 0, 1, 2, and 4, every other node there is. And then node 4 is connected to nodes 1 and 3. So yeah, that's the adjacency list, and you can verify this by looking at the graph again. So yeah, node 3 does really connect to every other node, and node 4 only connects to nodes 1 and 3. So yeah, that is the adjacency list. And then let's prepare another list called visited. So this is going to store all the visited nodes. So, and then this is going to be a list of bools, and each bool is going to represent whether or not the node at that index has been visited. So we have like a bunch of falses. So, and then these falses, so this is index 0 and then index 1. So essentially, if this is false, then that means node 0 has not been visited yet. And then if this were true, God, I can't spell. So if this were true, then that would mean that node 1 has been visited, whether from node 0 or from node 3 or from node 4. It has been visited, it doesn't matter which, so we can't come back to it. So let's just let's just do for I, since we have 5 nodes. And then let's build the depth first search function. So let's call it DFS, and then the node number here, specify that it's an integer. And then so first of all, we're going to check whether or not this node has already been visited. So if node, oh, actually we can just do this. Then we return, we exit out. Bleh. And then we are going to go through the adjacency list for that node. So for n for node in adjacency list node. So note that here we're essentially checking if we were traversing from node 4, then we would check the adjacency list for node 4, like right here. Yeah, anyways. So, and then we DFS, and so we woohoo recursion. Yeah. So this is basically for every node that it's connected to, it's going to try to traverse to that node. And then it doesn't matter if it's okay if the node has been visited before, since at the very beginning we just put if it has been visited before, we just put we just return out. And so yeah, somewhere inside this function you might want to change the visited list. So like maybe like something like this or something. And then since you're not just traversing for no reason, you can just put some of your other code here. So say if you're like checking the values of each graph or each node or something like that. So yeah, this is a simple way to traverse a graph without repeating any of the nodes that you have traveled to. So yeah, goodbye.